Good afternoon, everyone. Welcome to today's webinar, Revit Formula versus the Master Unit. My name is John Atkinson. I'm an application engineer here at CTC. And this is being recorded and will be posted up to our YouTube channel so you can access this later. So this webinar is a great overview of Revit's master units and how we use formulas from the essentials to the extreme. We probably won't delve too deeply into getting really complex formulas, but we will cover the basic formula structure for conditional statements all the way through stringing formulas together and nesting them along the way. So Revit can be really basic or really complex. It's one of the most underutilized tools is the formula column in our Revit families. So, if we have things that can be calculated, put down your calculator and put it in your families. One of the other things you can do is return information based upon those calculations for maybe populating a text string or something like that. So our solution is learn how to use these formulas to do all of these functions, from locking value inputs to a predefined value to creating outputs based upon all these other parameters. And we also need to understand that each type of unit, from feet and inches to BTUs per hour, they have a master unit associated to them, and how Revit relies upon these to create accurate formulas. So with that, starting with master units, for each type of unit there's a master unit. Revit quietly converts all the other units in the background and runs its calculations and converts it back to the new unit, and then places that in the value column. So in project units, you can define which unit Revit is going to convert back to. In the case of electrical, you could use watts or you could use volt amps, something like that. But one of the most infamous master units in the past has been temperature. This particular unit is Kelvin. So this in the past has required us to do some pretty confusing workarounds to get a proper value back out of it. And I'll give you a little demonstration of that in a little while. So during the creation of our formulas, it may become necessary to make a value unitless, which means to remove the unit designation from a parameter and then use that number within the calculation. This is typically accomplished by dividing that value by 1, and Revit's going to automatically place a unit designation at the end of that division. It sometimes works well, other times doesn't work well at all. Good example is when we need to calculate like velocity of a fluid through a piece of equipment. We have the value of GPM, but we need to calculate that to feet per minute, actually not feet per second. So feet per minute is gallons per minute divided by the area. If we put in our GPM divide by 1 to make it unitless, you'll see Revit automatically replace that unit with 0.13 CFM. CFM is the master unit for flow. So be aware of this. Revit will also substitute other units that may or may not make any sense at the time. Formulas can be used for math, algebra, geometry, trig, conditional statements. As we're generating them, we can compare elements with if, and, or, not, yes and no. We can round our values up or down, or either. We can use text strings or return text strings, and there's no limit to the length or complexity of a formula. One of the things that I typically do when I'm writing out my formulas is I might write them in Notepad++, which gives us some nice highlighting for parentheses and things once we start digging into nesting. I write in Notepad, Word. Sometimes I'll even do it in a draft email. And one of the best resources I've found for good examples is a forum post titled Revit Formulas for Everyday Usage. Also, the Revit help for conditional statements and formulas, if you just want to search that, also comes up with some good information. And here's the outline for a basic conditional statement. The equals is implied in our statement, in our value. We add the if, and then a parentheses, the condition we're trying to compare, a comma, the value if that condition is true, followed by another comma, and that value if that condition is false, and then a closed parenthesis. So where the condition is the comparison using conditional operators, and those operators are less than, greater than, equal to, and, or, and not. In your statement, always remember your parentheses. You have to have the same number of opens and the same number of closes for that statement to work. Commas are used to separate each part of the statement, and we can also return text strings. Our conditional operator examples, so less than or greater than, we'd write that out as if A is less than B, then return A, or whatever value that's going to be. If not, return B. With equals, we'd format that by saying if A equals B, then maybe some form of arithmetic in the true column, A times 2, or if that's false, B divided by 2. An AND statement means that both of these statements, so if A equals 1 and B equals 2, then return C. If neither one of those is true, then return D. With an OR statement, we're looking at A equals 1 or B equals 2. If either one of those is true, return C. If neither one is true, return D, or whatever your value is. Now, a lot of people like to use less than or equal to, or greater than or equal to. In order to use those, we have to use a not statement. So if we're actually trying to say X is less than or equal to Y, that would actually become X is not greater than Y. And we'd see if parentheses not parentheses X greater than Y as our condition, close parentheses, comma, if true, otherwise if false. Nesting our conditional statements, we have 3 different ways that we can do this. My preferred method is having the nested statement in the false portion of the statement. And in order to do that, we would start off with if this condition, then true. If not, move on to this next statement that compares an additional condition. And we can keep layering those on until, until we run out of ideas. You can also place those nested statements in the true portion. So let's say you wanted, if A is greater than 0, then go on to the next statement. If A is greater than 1, move on to the next one. If A is greater than 2, and you can do so on and so forth until you get to the very end. Then you'd put in, well, if A was greater than 0 but not greater than the following conditions, then return this value. You can also place it in the condition if you were trying to compare multiple parameters versus each other. You could put that in the condition itself and return different values. In this case, we have, if this condition here is true, we provide a value, and if that value is less than X, then it's true. Otherwise, return a false statement and move on. So now we jump into Revit, take a quick look at things. And I want this version. So if we need to lock a text string, there's one way that we can do that, and that would be quotations and end quotations. As soon as I hit enter, it populates my value over here and grays it out. That means once it's in the project, this is no longer editable. But one of the things we could also do would be, let's say if this yes checkbox was checked, we could place in here, if parentheses, and then our parameter name, yes, sample, then text here, otherwise, no text. And then we close that. And if I check that off and on, it's going to edit that text string. Now, conditions with yes, no, you'll notice as long as that is true, we don't have to worry about it. Otherwise, we could say maybe size sample equals 1/2 inch. And if this changed to maybe 3/4 of an inch, that's going to populate the next text string. So a key thing about this portion, if we're going to put in parameter names, they have to be exact. One of the ways that we can do that is simply by copying and pasting into our values up here. To control a yes, no, maybe I want to lock that yes, no checkbox. I can say 1 equals 1 or any other true statement. And you'll see it grays out. It's uncheckable. As long as this statement is true, that's going to check. If I said 1 equals 0, that is not true and it'll uncheck that box. Another thing that we can do with yes, no is say if we only wanted this one to be the control and this one to reference it, we would say not yes, sample, and leave it at that. Now every time I uncheck yes, sample, that no sample is going to check. If we take off the not, then those are going to be the same. And we could actually get rid of these parentheses on that particular statement. Now you'll notice on my feet per minute sample here, I've pasted my GPM flow from up here. It's 2 GPM. And I tried dividing it by 1, and Revit automatically put in square feet. Now I'm taking my size sample and I divide that by 2, but it automatically put in feet. Neither one of those is correct. So if I actually delete these out and said divide by 2 so that I can square it and then multiply by pi to get my area for that cross section, it keeps putting in that 2 feet, but I want that to be inches. So what I'll do is I'll actually multiply that by 1, come back here, change this to inches, and change this to GPM. I hit enter. It automatically puts in the feet per minute multiplier to add that unit back in, but it also converted it to 0.13 CFM. So we're getting, and CFM, I put a note down here, equals 0.1337 CFM. Now looking at temperature, if I had temperature here and said I have temp 1 at 180, temp 2 at 150. If I copy temp 1 down to my temp sample, that works. That gives me 180 degrees Fahrenheit. If I copy temp 2 and say temp 1 minus paste, I get inconsistent units, but they're both Fahrenheit. So what can we do about that? We can add 0 degrees Fahrenheit to that sum, and that's going to give us 30 degrees Fahrenheit. If we took a look at release 2016, that one, I can do temp 1 minus temp 2. So anything prior to 17, we can do this. But what Revit's doing is in the background, it's converting temp 1 to Kelvin, converting temp 2 to Kelvin, subtracting them. I believe it's getting something like 11.11 degrees Fahrenheit or Kelvin. And then it's converting that back to Fahrenheit. So again, what we'd have to do is add that plus 0 degrees Fahrenheit here to get that 30 degrees Fahrenheit. Not always the most straightforward, but we do have our workarounds and our tricks to get Revit to return the values that we need. Now one of the other things we can do, you'll notice I have size lookup here. Size lookup is my function and then it's looking at a lookup table name. So if we go back to our PowerPoint, adding the lookup tables allows us to simplify a series of nested statements. We can create a table of values to say if column or parameter B, C, and D all meet these criteria, return this value. So here's the format we would have. Size lookup is the function. Lookup table name is the parameter name for the lookup table. So that could be, you could just say lookup table 1, lookup table 2. You could have multiple lookup tables that you're referring to, and they differ a little bit once we get to this area after the comma is default. So this is different than our conditional statements in that the default value that it's returning, or if false, comes before any of the other information. And then the lookup table starts looking at column B, then any other columns you have after that. So I have a quick little piece here. So here's one series. I have column A is my description. I can put anything I want in here. Column B is the first column that your formula is going to look at. You don't have to worry about the name. You only have to worry about this particular one is length and inches. So it's looking for ½ inch in this case. The next column I've labeled GPM. This is other number, and then in column D, this is actually what I'm going to be looking at. So if we take a look at our sample in Revit, I've got size lookup, my function, and then lookup table name, which is sample lookup. And down here on the bottom right, we have manage lookup tables. And this is where I would import this. I'd say import sample lookup, and that has to be a comma separated value, so a CSV file. Import those, say OK. Now anytime I say go to lookup table name, it's going to immediately look for that particular lookup table. Next, in quotations, we put in the name of the column. So in this one, sample. We're looking for this name. I could call any other column as long as we use the correct name. 0 is my default if it's not finding anything that matches these values. So it'll keep going, looking down this column first and then this column. If it doesn't find any that match, it's going to return 0. If it does find ½ inch and 2 GPM, it's going to return 250. So size sample, I could, instead of having it look up here for this value, I could tell it to look for a specific size. If I said ½ inch and 2 GPM, it's going to return that 250 value. If I put this back in, delete, there we go. Now it's going to read based upon this size sample. I change that back to 1/2 inch, it returns my value. Next, I'm actually going to look at GPM flow. This is my next column. So this one is B, this one's going to be C. But in order for me to use this, I need to make this unitless. The unfortunate thing about making that unitless is that this does not return a whole number. So my value becomes 0. This is where that rounding function comes in. I can round that up or down. If I said round up, it's not going to work. If I said round down, that would work because we're actually having small decimals close to that 2 number that we're looking for in the table. Now if I change this to 3 GPM, it goes to 0, but if I change this one to 3/4 inch, now we're back up onto our table at 750. And here's our value. Like I said, we can have as many columns as we want. I could add an additional column here looking for maybe, call it a number, a value, and it's going to look in column D for a number 4 before it starts pulling the sample column. So we can make incredibly complex lookup tables to return many different kinds of data as long as they're number values or angles or lengths. So the lookup table, again, here's a quick overview. Size lookup is the function. The lookup table name is that parameter name. And then parameter name up here in quotes is our parameter name. Then default, if it doesn't find anything, then we start at column B and keep going from there. You can have as many or as few with a minimum of 1 for the number of columns. And then column A is simply our description of whatever that row of information is providing us. So commas and parentheses, again, are really important. Values from the lookup tables can be numbers, links, or angles. And we can use those parameter values as long as they're unitless. And at the very end, we could multiply that value by a unit to get our value converted. In this case, it would be CFM.